Yeah. So first thing that of course we talked about when we were in the lab was hazard symbols. So I would suggest you look at different hazard symbols and identify what they mean. Uh, like you should be able to identify them. Similarly, uh, the second idea is using the periodic table. In the periodic table, you have groups, you have columns. So you should be able to figure out which group something is in based on the column, and you should be able to figure out which period something is in based on the row. So if I tell you calcium, and you should be able to identify that, oh, calcium is in this group and calcium is in this period. Similarly, if I give you fluorine, you should be able to figure out that fluorine is in group 17 and it's in period number 2 because it's in the second row and all that. Similarly, sometimes we get this symbol, like, for example, if we got F with -1 and 19 and 9, you should be able to figure out that, oh, okay, from this symbol, I can identify protons, neutrons, and electrons. Similarly, if at the same time I gave you another one, which was 9 and 18, you should be able to figure out that, oh, these are different isotopes. Okay. So that's another important idea from grade 9 that you need to remember. Similarly, from grade 9, you also need to remember the different reactions that acids bases do. So acids have what? They neutralize alkalis, right? You need to know the definitions. You need to know how do they react with things. For example, acids and metals, acids and bases, all that kind of thing. So for example, if I take HCl, HCl reacts with sodium in a way that sodium displaces the hydrogen. Now, this is reactivity series that we talked about. Okay. So because sodium is higher up, hydrogen is lower, sodium will simply displace it and so form sodium chloride and hydrogen. Then you also need to know how to balance this equation. So 2 here, 2 here, and 2 here. Why? Because I had 2 hydrogen here, and this is 1, so 2 times that is 2. Similarly, because now I have 2 Cl, I'll have to put 2 here to make it balance, and then I'll have to do 2 with sodium to cancel it out. Similarly, what happens when, so this is acid and metal. What if I had acid and an alkali, like NaOH? In this
salt
case,
and water.
Salt and water, exactly. So you should be able to name the salt, and obviously, you know, water is going to be formed. Similarly, if I took the same HCl, what reacted with it? Calcium carbonate. Sorry. So in this case, first of all, carbonate is going to break down and give you carbon dioxide. And then you're going to get salt, water. So water is formed. The key question is, what salt do you get? So you have calcium here, chloride here. So you get calcium chloride, CaCl2. You need to be able to identify the formula. And how do you name the formula? I would share the recording of the lesson we had with grade 9, review the whole grade 9 syllabus. So you can just study that one. There's also a video on the YouTube on my channel if you want to review it. Okay, so that was that. There was another reaction, which was precipitation reaction. Precipitation reaction is that you can use 2 solutions to make insoluble salt. So for example, if I had silver nitrate and they reacted with HCl. Now this is soluble, but just because they react, they can interchange. This is also called double displacement. So silver can come in place of H and H can come in place of silver. So you get HNO3 plus AgCl. And this is an interesting one because HCCl is insoluble. So remember the solubility rules that we talked about? So go over the video for that. Okay, so see the solubility rules video for this one. That's a 5-10 minutes video. That's pretty straightforward. Yeah, another important question was, how are metals and non-metals different? Again, this is from grade 9. We know metals are different from non-metals because in terms of their bonding, metals have free electrons, non-metals don't have that, except for graphite. That's an exception. Similarly, metals have high densities, non-metals don't. Metals are on the left side of the periodic table, non-metals are on the right side of the periodic table. That's not something you can write, but that's just something that there is. and what kind of bonds do they form with each other? So metals usually form ionic bond when they react with non-metal. They transfer electrons. So that whole thing is also important for you to remember. What else was in your syllabus? Yeah, there was a concept of water of crystallization. So water of crystallization, what was that? It is the water molecules that are attached to any salt to form the crystal. They act as bridge between different crystals. So usually we write them as, so for example, cobalt chloride, we write them as 6H2O. So what this is telling me that with one cobalt chloride, I have 6 water. So with 2 copper chloride, how many water will you get? 12. With 0.25 cobalt chloride, how many water will you get? 1.5, because you just multiply. So whatever this number is, it multiplies with this. So if this was 10, this will be 60. If this was 1/4, this will be 6/4. That's the idea there for water of crystallization. And how do you make sure that when you're heating things, they don't go away? So if you want to keep water of crystallization, you heat to saturation point, okay, and slowly cool. This way, water of crystallization remains. But if you want to get rid of it, you heat to constant mass. And we talk about this in detail on the salt prep. That's another video that I've uploaded for you guys. So you can go over there. So there are basically 4 or 5 videos that I want you to review. I actually thought that you would have reviewed it by now. So in case this session was supposed to be a question answer session, but aap log to jaag hi nahi rahe. Then there was the idea of organic compounds. And how do you name organic compounds? So I'm going to pick an example from each organic like homologous series that I have, and let's try to name them, draw them, and see how you can like work with them or the properties. So for example, I'm going to take the example of 2 carbons, okay? So I have this thing. Can you name this?
Methane.
No.
No,
Ethane.
ethane.
Yes, very good.
Ethane.
Ethane, very good. Very good. Okay. Will this burn? Like, can we do combustion with this?
Yes.
Yes.
Yeah, we can. Yes. What will its formula be?
C2H6.
C2H6.
Yes, very good. Okay. Let's say I have the ethene. What will its formula be?
C2H4.
Very good. And the structure?
A double bond with C.
Carbon
A
double bond.
with this.
H.
Very good.
Okay.
Now, you should be able to draw this structure as well as the other structure. So for example, in this case, I can write this structure as well. Like, instead of drawing a line, you should be able to draw this. Have you seen this before?
Dot and cross diagrams.
Yeah, exactly. So you should be able to draw it for this one as well, that between these C's, you have this. So yeah, you should be able to draw it this way as well. Okay, let's look at ethanol. So what will the formula be for ethanol?
C2H6OH.
H5OH.
Oh, okay.
Yeah. So this will be C2 and 1 hydrogen is replaced with OH. Or if you draw this structure for this is called a Louis dot structure, okay? So, or dot and cross. So you just need to know, if you know this structure, just replace every line by a dot and a cross. So if you have 2 lines, that's 2 dot and cross pairs, and that's how you get this thing. Okay. So that's this. Then we have acid. So ethanoic acid. What will its formula be? Now, acids are interesting because they already have a carbon in their group, the functional group. CWH is already there. So that means the remaining part will just have what? It is ethanoic. So one carbon is there. So the remaining one will have just one carbon. So CH3, CWH. If it was propanoic acid, it will be C2H5, CWH, because one carbon is already in the functional group. So its formula will be this. So COOH is the characteristic functional group that they have. And then I need one more carbon. So there you go. That's the formula. Or I can just write it all like this. Now, because oxygen and carbon, they have a double bond, I'll have two pairs of these dot and cross here. Okay, and that's an important point to remember. So what I always do is that I draw this first and then I convert it to this, because that way it's very easy, very convenient to do that. Okay. Of course, it's an acid, so it reacts like acids, and that is why reviewing grade 9's acid reactions is important, like reviewing this thing, because all of these things you can replace them with any ethanoic acid, for example. So the HCl reacts with sodium, ethanoic acid will also react with sodium. How does it do that? Let's look over here. Let me try to write the equation. So ethanoic acid is what? CH3, COOH. So it reacts with sodium. So what happens? The H goes away in place of sodium, because again, remember, what do acids do? They give H positive. So Na comes in place of this thing. So you have what? You have CH3, COONA, and hydrogen gas. And then, of course, you balance it out. This 2 hydrogen, this is 1. So you multiply this with 2, which makes you multiply with this with 2, and then you multiply this with 2. Similarly, will this thing react with NaOH? Of course, if HCl reacts, this will also react. The difference is, again, H comes in place of Na, and you get this thing plus water. Will this react with carbonate? Of course, it will. You'll, again, calcium will come in place of this, and you'll get CH3COO reacting with calcium. Now you have to remember that calcium has a positive 2 charge, and this thing has a negative 1 charge. So that means the 2 comes here and the 1 goes there. Again, this is from the formula making video or the grade 9 lesson that we just had. So you should review that as well. And of course, it gives you carbon dioxide and water. And how do you know the reaction is happening? You can bring in the idea of rate of reaction. So bubbles of carbon dioxide are coming in, and as long as the bubbles are there, the reaction is happening. Okay. What was another question?
Sir, in chapter 10, there was something about like entropy and Gibbs energy, which I did not like fully understand. I know we did enthalpy, and I was just wondering if entropy and Gibbs energy is also part of our syllabus.
We can review it. It's not strictly in part of your syllabus or strictly outside your syllabus, but I don't think we need to review it at this time if you haven't done it, because chapter 10, I think you did it with the previous teacher. So if you haven't done it, then I would suggest we don't review something new at this point. We just review what we already know.
Okay.
Yeah. By the way, if I gave you an acid, how do you know, how do you neutralize it?
Reacted to the base.
Exactly, reacted with an alkali. So in theoretical terms, you simply, so this is neutralization. You take an alkali, sodium hydroxide is a very good example, and you react with this, it will neutralize it. And how do you do it practically? Through titration. Okay, so you take it in a conical flask, you add the the indicator. So we used methyl orange in class. You add the base from the burette until you see the color change, and that's when you stop. So you have neutralized it. Okay. That was done. What else do you need to know? I think rest of it is simply criterion B, identifying the independent variable, the dependent variable, and I've shared multiple worksheets for that. So you can also practice from the past papers that I've shared with you. Also, in rate of reaction, the idea of what factors affect the rate of reaction are important. So if I'm comparing two things, and there is the idea of collisions, okay? So if there's more effective collisions per unit time, then the rate is faster. So there's 5 factors in there: temperature, pressure, surface area, concentration, and catalyst. Okay. So all of them affect effective collisions per unit time. But do you know how they do that, and how you can see that in a reaction or in the lab? So let's talk about them one by one. So temperature. I have two things. One is hot, one is cold. Which one will react faster?
The hot one, because of the kinetic energy is
Why?
Because it gains more kinetic energy and then more effective collisions, and then the reaction is much faster.
So more effective collisions per unit time. That's important, because ऐसा हो सकता है कि overall, when the reaction is completed, they both have the same number of collisions. Like if they both do 10,000 collisions, they both might have done 10,000. But one might have done 10,000 collisions in 2 minutes and the other might have done in 2 hours. Right? So it's more effective collisions per unit time. That's important. Okay, pressure.
Particles are closer together, so there's more collisions per unit time.
Yeah, so they collide more, so more collisions per unit time. Again, it only affects gases. That's important. So if there's solids or liquids, pressure doesn't have any effect on the rate of reaction. Okay, surface area.
Collisions happen to the surface of an object, so if there's more surface area, more collisions happen per unit time.
Excellent. So how do we see it in the lab? So for example, I remember we did this with lumps of calcium carbonate. So we had a powder and we had lumps. So which one had greater surface area, the lumps or the powder?
Powder.
Powder, yes. And if you remember, we weighed them and they both weighed the same. But when we reacted them, the powder gave us much rapid bubbles than the lumps. Why was that?
Greater surface area.
Because the
Exactly.
particles were direct in contact with the surface. That's why.
Yes, at the same time. And interestingly, the carbon dioxide that they made, it was the same in both cases. We did not record it in the lab, but theoretically we know that the carbon dioxide that they made must have been the same because they weighed the same. Okay, so that's an interesting thought. If we do not want something to break down, or we do not want something to react, then we would want it to be in lumps. That's an angle that examiners sometimes takes. Like for whatever reason, if we don't want something to dissolve, then we will give it a lower surface area. But if we do want something to dissolve, we will give it a higher surface area. Okay? Or to react, we'll give it a higher surface area. So if sure, our focus is always on rate of reaction being faster. Sometimes we do want the rate of reaction to be slower. Okay. So for example, if you're drinking coffee and you want, for whatever reason, you want the coffee to be sweeter the more you drink it, then you will use lumps of sugar. You will not use powdered sugar, because then the whole coffee will be the same. So just a thought. Anyways, concentration. Concentration is simply the idea of more particles per unit volume. So if you have higher concentration, there's more collision per unit time. And if there's low concentration, less collision per unit time. So that directly affects the rate. And what about catalyst?
A catalyst lowers the
Catalyst.
activation energy and gives another pathway for the reaction to happen.
Yeah, exactly. And that pathway has a lower activation energy. And one more important thing, catalyst stays the same at the end. Okay, that's another important idea. Then we talked about, I think we talked about the fuels when we were talking about energy, and we talked about how petroleum products are separated from each other. So that's another important thing in organic chemistry that I would like you to review. The process we use is fractional distillation. So that will be a good idea to review what kind of substances are separated first. So fractional distillation is all about boiling point. We separate things based on their boiling point. So the things with lower boiling point, they go to the top. The things with higher boiling point, they stay at the bottom. And that is how we separate them. And of course, smaller molecules have lower boiling point and larger molecules have higher boiling point because of greater surface area again, or stronger force of attraction. So fractional distillation and identifying what kind of fuel we have. And for example, remember we talked about petrol fuel being like petrol molecules being smaller than diesel molecules. So they break down faster, they're more, but they're lighter as well. They're collected first, all of that. So there's this diagram on this in your book, which is about a tank, and the tank has these different openings in there. So the fuel comes from this side and we heat it. So the lighter ones are collected here, the heavier ones, as you go down, they get more heavy and heavy, and they have different uses. For example, there's this one, which is the camping gas. Then there is petrol, there is naphtha, there is
Kerosene.
diesel, kerosene, which is also jet fuel. You also need to know use of each one of them. Like camping gas, of course, it's used for cooking. Petrol is used for petrol cars. Naphtha is used for, what
Sir,
was naphtha used for? Yeah.
sir, I have a question. Are the other separation techniques coming except for fraction distillation?
So
are we supposed to
because
know
we
them?
focused on organic chemistry, then only this one is important. But for acids and bases, filtration is important. Filtration and crystallization. So
Okay.
those are the two that I would suggest you review. I think that is all the important things that I identified from your chapters. But if there's any questions, do ask, because again, my idea
Filtration
was
and-
that you would have. I'm sorry?
Filtration and
Filtration, crystallization,
Oh.
all of that. Yeah, because in acids and bases, that's important. And in organic chemistry, fraction distillation is important. Okay then. But if you have any questions, feel free to email. I'll be happy to help. I'll also share the links to the videos that I was mentioning.
okay.
Okay, take care. Bye.